Welcome back to Spreader Web Education. Today we're going to take a look at creating a logic circuit from a truth table. We're going to take the truth table over here and we're going to take it all the way to a circuit. Then we're going to simplify that circuit using Karnaugh mapping. If you're following the series, you realize I've skipped the NOR gate. I think if you look at the lesson on the NAND gate, you'll be able to figure out the NOR gate fairly easy. Going back to some of the other videos. So alright, let's start with the table. What the goal here is I want to create a circuit that's simply going to turn on an LED given a certain sequence of numbers. So we have to remember that we create these zeros and ones using our pull up or pull down circuits, and those are going to feed into our logic gates. So I'm not going to put those on this lesson. If you need to see those, go ahead and put it in the comment, and I'll create something different to show you what those look like. But they're fairly simple. I think by this time everybody knows what they should look like. But if not, put it in the comments, and I can make something. All right. So the goal here is with 3 different inputs, maybe 3 different switches that can give me a 1 and a 0. I want to pick a couple of these that when the switches are in the right states, I will turn on that LED. So I'm going to, for the sake of this lesson, I'm going to pick this is an output that I want for 1. This sequence I want is a 1, and this sequence I want is a 1. Okay, everything else is going to be a 0, which means when these 3, any of these 3, here, here, or here, are true, I want to turn on my circuit. So here's how we're going to do that. We're going to do it by first creating a Boolean expression. So our Boolean expression, we'll take each one of these and add them together. So a 0, 0, 0 for A, B, and C is going to give us an A naught, a B naught, and a C. That's a 0, 0, 1. Then I'm going to add that to the 1, 0, 0, which would be an A, B naught, C naught. And then I'm going to add that to the 1, 1, 0, which would be an A, B, C naught. And that equals Y. That is my Boolean expression. Now that expression, if you look at it closely, you can tell this is an AND gate, A times B times C. This is an AND gate, A times B times C, and this is an AND gate, A times B times C. We've learned that in the other lessons. But what we'll be doing is we'll be taking all 3 of those 3 input AND gates, and then we're going to OR them together. That's what that plus is. So these 3 will be ORed together. So I'm going to, this may get a little bit sloppy. I'm going to use different colors to try to make it sense. But if these are my 3 switches, again, these would be like pull-up or pull-down resistors, or pull-up or pull-down circuits giving me a input. I'm going to create then a circuit using, again, the 3 input ANDs. So there's one AND, there's another AND, and there's the third AND. And those will be ORed all together. Kind of a sorry looking OR gate. And that's my Y. This is where I would hook up my LED and have it turn on. So what I want to do is put this configuration in for these 3 that would give me a 1, which is why we picked those 3. So to do that, for A, let me use a red here. I'm looking at, or for the first one I should say, for this one, I'll color that in red. It's an A naught, B naught, C. So I would need from A, I would need to invert A, that would give me an A naught. Then I would have to take a B and also make it a B naught. But then the C can go directly up. You can see how this is going to get messy real quick. For the next one, let me use blue. It's a B naught, C naught. So I could take this A and feed it into that AND gate. Then I need a B naught. I can grab that B naught from right there and go in. Then there's a C naught. So that's a C. I can make a knot out of that. That's using the NOT gate into that AND gate. And that covers that one. Then I have an A, B, C knot. So let's change up the colors even a little bit more here. I can't really use black. Let me use purple. All right. So that's an A. Well, that's an A right there. So I can kind of tap into that A. B. B's right here. I can tap into that B. And again, you can tell this is pretty sloppy. And then a C knot. That's a C knot right there. And I can tap into there. So I got A knot, B knot, C. I got B, A knot, C knot. And I got A, B, C knot here. If I take all those ands and then I OR them together, I get my Y. Now, this circuit would work. I could add the pull up or pull down circuit over here. I could put in a 0, 0, 1, and I would get a 1 on the output. I would put in a 1, 0, 0, and I'd get a 1. I put in a 1, 1, 0, and I would get a 1. Any other configuration would give me a 0. This is nice if you want to use it for a locking mechanism. You could do 4 inputs, and out of all those 4 inputs would be a much larger list. I could just make one configuration and turn that into a locking mechanism. So you can do a lot with these logic circuits. But let's do something a little bit different here. What I want to do is I want to simplify this. This would not be easy to build. You got a bunch of chips, a lot of wires. But let me introduce Karnaugh mapping. Karnaugh mapping is the simplification of this circuit. We want to make it as easy as we can. So for a 3 input, our Karnaugh map, and I should have probably drew this earlier, our Karnaugh map would look like this, where down here is my C and here's my A, B. So I'd have a 0 and 1 for each one of those rows. Then I would have a 0, 0 for here. I would have a 0, 1, a 1, 1, and a 1, 0. Now, what I do is I fill in the Karnaugh map. Let's use red. I'll fill in the Karnaugh map with what I have in my table. So I have a 0, 0, a 1. 0, 0, and a 1 for C is here. I have a 1, 0, 0. 1, 0, 0 would be here. A 1, 1, 0, 1, 1, 0. So that would fill my Karnaugh map. So what I do is I group them together. Anything that's touching, for instance, these two, if there were 2 here, if there were 2 vertical, I could do those. If there were 4 here together, I could combine those. Here we only get these 2. Now what I do is I combine these. There's nothing to combine with this one, so I'm just simply going to write that one down, which was the A naught, B naught, C. But then I'm going to add that to these combined. So I'm going to AND these together. So I would end up with an A, B, C naught, and an A, B naught, C equal to Y. So here's where the simplification comes in. I can't really simplify this, but if I have a B and a B naught here, I can cancel those. That's the only simplification I can do. So now my equation, A naught, B naught, C, plus I messed up. That's supposed to be a C naught. C naught equals Y. So you can see this is much more simpler than this, but it does the same thing. So now let's do the circuit for this. Here I only have 2 AND gates, and those are going to feed a 2 input OR gate. I still have my A, B, and C over here, and again these are my inputs, my lower high that I create. Now I have an A naught, B naught, C, so let's go with a red. So I have an A naught. This really hasn't changed from the first one. A B naught and a C. Sneak that up there. But on the bottom one here, this is only a 2 input AND. I have a C, change colors again. I'm sorry, an A, so I can grab the A right there before it's a not. And I have a C not, so I can come in off of here, put that in a not gate. Now, if I put a 0, 0, 1, a 0, 0, 1, I'll get a 1. If I put a 1, 0, 0, a 1, 0, 0, I'll get a 1. And likewise, a 1, 1, 0. 1, 1, 0 will give me a 1. Any other configuration in this table will give me a 0, which of course won't satisfy the requirement to give me a 1. All right, so let's recap. We have a table. Try that again. We have a table. Here's our table. We can choose the states that we want to have a 1 at. We then create a Boolean expression. We build the circuit, or design the circuit. But as you can see, that circuit's not exactly the easiest. We can take it over here to a Karnaugh map. We can take it through the Karnaugh map and simplify it, and then build the circuit from there. That would be much easier to build than this monstrosity here. All right, so thank you for listening. This is probably going to be the last, possibly the last lesson on logic gates. If you have any comments below, or you want to see any other examples, you can also do 2 input and 4 input, but it's the same thing. You just have a different Karnaugh map, and this gets really sloppy. But if you have any comments, you want to see anything else, please leave them in the comments below. And as always, please subscribe to Spiderweb Education.